My name is Eric Sproul, and I'm going to be talking about what we do at Circonus to deliver our software both as a public SaaS and as an on-premise solution. A little bit about me. I do release engineering at Circonus, and that means that I'm in charge of the continuous stuff, integration, delivery, whatever you want to call continuous. It involves a lot of software packaging and the orchestration of deployment of the entire product on-premise for some of our customers. So some of the stuff I want to go over is a brief overview of what Circonus is and some of the challenges that we face and the philosophy that we've developed to cope with those challenges. We'll go through our automation processes and how we actually develop and release changes. Take a diversion into packaging for OmniOS because our public SaaS runs on OmniOS. So you need to understand a little bit about how it works. I won't go into all the detail about how to create packages, but it's a topic that I'm very passionate about, so happy to talk afterwards about that. And then finally, how we get all of those bits into a customer premise. So briefly, Circonus is a SaaS solution for monitoring and data analysis. It's a SaaS website where you can just put in a credit card and sign up. Or if you are a large enterprise, you may choose to run a private version of the SaaS. It's all the same tools. It works exactly the same way. It just exists on your premise. Everything is pretty much distributed. We have a number of different components that all work together. And we run on primarily OmniOS, but we also support Linux. CentOS 6 is the other platform that we build for. So like I said, everything is all SaaS. You can sign up on the public site with no software to install and just use it through your web browser. We operate the one true copy in that case. And we have been growing rapidly over the last few years. We've been in existence for about 5 years, and at this point we are doing 6 billion data points a day, and that's only going up and up. But there are reasons why you might want to not use the public SaaS, and the biggest one that we get a lot is that people have policies that their data can't leave anything that's on their premise. So they need to run a full copy of the SaaS on their site. They also may be operating at a scale that is far beyond what the public SaaS can actually do. And in fact, most of our on-premise deployments dwarf the public SaaS. They are much larger. The way that we achieve scale is by distributing and loosely coupling components. This is a pretty common strategy these days. There are a host of different kinds of applications that we employ: front end, middle tier, message queues, internal APIs and external APIs. And the heart of the whole system is a proprietary time series data store that we did. Because when we started, and even as recently as the last couple of years, there isn't really another product that can operate this at the scale of incoming data that we have to manage both in the public SaaS and for our on-premise deployments. So we pretty much had to set out to write our own, and that has proven to drive a lot of value in the product. We can store minimum 1-minute resolution forever, for effectively forever, 5 years, 7 years, whatever the list is. I think in SaaS we promise 7 years of retention, and that's full resolution forever. It's a large stack. We started out just doing public SaaS, so we thought, it's SaaS, there's one true copy. It doesn't really matter if we have a whole bunch of different components. We're going to pick the right tool for each job. So we're going to use Java for like complex event processing. We're going to have streaming go through Node.js. We're going to have like Apache and all these different things. But if you turn around and say, well, it turns out there's still a market for shipping people software that they run on their own machines, that's crazy. Like you wouldn't build the product that way. But we had already been running the SaaS for a few years when we started shipping the inside version, and so here we are. This is the challenge that we have. We have all these software packages, language runtimes, modules, and the vast majority of that list of 300 packages is just dependencies for the applications that we actually create. And we have to deliver it both on OmniOS and on CentOS consistently, the same updates on both sides. So philosophically, this means that we really want to keep boundary around the things that we create. We want to keep our stuff to ourselves. We want to, as much as possible, control the versions of all of the dependencies that we have, because we have a lot of dependencies and there's a lot of relationships between them. So when you're looking at systems like OmniOS, which is an Illumos derivative, and CentOS, which is Linux, there's a lot of difference between those two platforms. They ship different versions of things, they're in different locations, they're built differently, and all of those things, all of those differences represent risk. So it makes it more challenging to develop something that works the same way across like major versions of Perl, things like that. So what we've tried to do is minimize the dependency of things in the host operating system. So basically, I mean, you can't really run without depending on libc, so we have libc. Things like zlib and OpenSSL are really tricky to do correctly if you're shipping multiple versions on the same host, because you have interrelated linking and runtime issues that can happen as a result. So it's not really a fixed thing. There's no one answer for should we depend on the OS version or should we build our own. Generally speaking, we start by trying to build our own, and if it really doesn't work out, then we'll use what the OS provides. OpenSSL is a good example there, because we initially wanted to have our own version of OpenSSL, but you run into problems where our app links OpenSSL and then it links another library that itself links OpenSSL, but it links the one from the host and not ours, and then you have symbol collisions and everything is sad. So we compromise in some places, but if we are going to build it, we make sure that it always gets installed in a consistent place that's obviously not part of the system. It's obviously something that we bring, and that allows us to control how often we update things. So if the OS decides that they want to upgrade some library, it's probably not going to affect us because we're already using our own. We want to package everything, even the cat. All of my presentations, I try to have at least one cute internet cat. So we really want to deliver everything consistently. So we don't want to have things that are like, oh, cpan install this Perl module, or npm install this node package, or things. We want to capture everything as consistently as possible, and we want those to use the native platform tools. So again, we want to just be able to yum install something or package install something. And we want it to be repeatable so that when customers are doing things on their inside installation, things work the same way. The product itself already functions the same way. It's just a web application, so whether it's running on Linux or OmniOS, from a user standpoint, it looks the same, but since people are operating the entire system themselves, we want the operators to have as much the same experience. It just works the same way. So that takes care of the overview of Circonus, and now I'm going to get into the release process and how we automate things. So continuous integration, I imagine everybody's pretty much familiar with the concept. We use Jenkins, and I'm not really passionate about any particular CI tool. It works. It lets us do what we need to do. We build most of our applications every time that there's a commit. Or sometimes there are just so many commits that we just build it occasionally on a fixed schedule every day or once a week or something. We run any test suites that are involved in that source, and then we kick off a downstream job to create an OS package. And to do that, we actually have a fork of the build system that OmniOS uses. It's really, really handy, really easy to grok. It's mostly shell scripts and shell functions. It's bash-based. It's pretty easy to get into, even if you're not a developer, which is like me. I come from an ops background, so shell scripts, I'm all about that. And what we did was we added the ability for a single build script to produce either an OmniOS package or an RPM, depending on which downstream executor you're running on. So this is just a simplified diagram of what happens when we have a commit. So a commit will happen, and in this example, I'm using Reconnoiter, which is an open source software tool that we wrote. It's the basis of our broker software. The broker is a software appliance that is gathering the metrics and feeding them into the system. So the broker is the point where metrics actually enter the system. There's a network of public ones around the world that you can use if you're on the SaaS site. If you're inside your data center and things aren't exposed to the internet, you can download our broker software and install it inside your data center so that all you have to do is let us come into that one location and siphon off all the data. So the Reconnoiter is the open source code base, and we add on top of that some other things, some web UI and some provisioning shims to be able to attach it to the SaaS infrastructure. But when a commit happens in Reconnoiter, there will be a Jenkins job that compiles it and then runs the test suite. And assuming all those things succeed, it will kick off a downstream job that checks out the build repo and runs the build script for the broker. Now, there are multiple things because there's other code that goes into the broker. This is actually oversimplified because there are multiple things that can trigger that broker package build. But the main driver is the main bulk of the source is in Reconnoiter. So that's usually where we get triggered on that. And the delivery part of this is a little bit different depending on whether we're talking about the public SaaS or the private. So I'll start with the public SaaS. We follow the usual dev, stage, production. We deploy from master, so that's something that we kind of share in common with the Illumos community. We want the master branch, the tip of master should be production quality at all times. So you don't put things in until you've tested them and you've made sure that they're good to go. Developers can push their own changes. We have a one-button deploy, so you can push your changes out to stage and have them tested, and then do another one-button deploy to push them into production. And the difference to the inside stuff with public is that in the public SaaS, the main web application itself is actually a checkout. We don't use the package for that component just because there's such a velocity of change that happens on that repo. There are multiple changes per day and multiple pushes per day potentially that could happen. And if we had to wait for a package roll and publish and download and install each time, it would really slow down the development cycle. So for that reason, we keep those as checkouts. But our philosophy is to fail forward. It's the DevOps way of small, discrete changes that are easy to identify if they cause bugs in production, and then you can quickly fix them and move forward. So for on-premise releases, though, we want to stick entirely to OS packages because obviously we're not going to let our customers check out from our repos, and they also don't typically want to get every single change as soon as we make it. Even though we're pretty confident in the changes when they go out to production, obviously enterprises work a little bit differently, and so the compromise that we've been able to come up with is to have a weekly cadence to our releases. So the main web application, like I said, doesn't get a package roll every time there's a change, but once a week we will collect up all those changes and do a package roll. That's a scheduled job that happens in Jenkins, and it pulls in all of the changes for the week and publishes a package. And then we have a gating package, which I'll get into when I talk about how OmniOS packaging works. We have a gating package that takes not only that web package, but any other package that has changed during the week and captures all of those updates that are going to happen as a transaction. And then assuming that we don't identify any show-stopping bugs over the weekend, come Monday, we will promote that out and let our customers have the update. Because some of our customers are happy to update every week, and some of them want to sit on things a little bit longer. They don't want too much change to happen in their copy, so they'll choose maybe to update monthly, or they'll wait till a bug fix or a particular feature is available, and then they'll update. So we don't really know when people will update, but if they want to update quickly, they can do it at least once a week. Okay, diverting a little bit into how OmniOS packaging works. It's a little bit different from things you might be familiar with. If you haven't experienced the packaging on OmniOS, it'll be a little bit foreign to you at the beginning, but I promise it will make sense, hopefully. when I'm done explaining it. So overview, the image packaging system is the name of the software that we use in OmniOS. It was developed by Sun for OpenSolaris, and it replaces the absolutely ancient and horrible System 5 packaging format, which everyone universally despises. That format was developed in a time when you delivered software on tape. So it's clearly long outlived its usefulness in the modern networked world. We are not the only ones using this. Some of the other Illumos distributions use it, and Oracle still develops IPS out in the open. It's the packaging system that's used on Oracle Solaris. The packaging system itself is open source, but it does have some dependencies on things inside Solaris which are not open source. So in order for the community, the Illumos community, to continue using PKG, we have to have a downstream repo and maintain a change set against that allows us to excise those features that depend on Solaris. There are not too many changes, and I have to give a lot of credit to a couple of the folks in the Open Indiana community who keep track of those upstream changes and have a downstream fork, of which OmniOS has another downstream fork, because we have some private changes to it as well. But they do a really good job of keeping up with the changes in that, so we get the benefit of the ongoing development that Oracle is putting into IPS. It's a transactional a packaging system. Everything is metadata driven, which I will explain as we get a little bit further in. It's all network based, so there's a repository, and you can go out and download the package contents that you want. And because of the extensive metadata, you can do changes only updates. So you can, if you have a package that has, say, 3,000 files in it, and you change one file, to update that package, you only need to get the one file that has changed, because it can look and see what the differences are between the installed version and the remote version. So a package in OmniOS is described by this thing called an FMRI, which is a fault managed resource identifier. FMRIs are all over the place in Illumos. Services use them, hardware components use them. It's all part of the fault managed architecture. So there is a PKG scheme that starts things off, and then the next part of the name is the publisher name, and a publisher is just some entity, a person or a company or a group of people that creates packages. It's a reasonably unique way to identify a source of packages. And then the rest of the name is divided up into an arbitrarily deep category, of which, in this case, the web service package. Web is the category, and service, being the last component of the name, is considered the name of the package. And then everything after the @ sign is a version. And I will explain how the version breaks down, because it's designed to be machine parsable. It kind of looks a little bit daunting for a human to read, but it's not that bad once you get used to it. The first part is the component version, everything up to the first comma there. That is the upstream software's version. And in this case, this is one of our custom internal packages, and we don't really have versions for anything, because everything's in Git, and there's multiple changes. So we struggled with what is the version of this thing? And what we settled on was just to use a Unix timestamp. And that timestamp is the time of the commit that makes up this package. So we figure out what that timestamp is. That becomes the version of the package. It's going to always increase. And by the time it rolls over, I hopefully will be retired and not in the business anymore. It won't be my problem. The next two parts are really not that important for the discussion here. Just briefly, it's the build version, which is pretty much always going to be 5.11 in the open source community. This was typically the version of the operating system that you were built on. So presumably when Oracle Solaris 12 comes out, that will change to be 5.12. But for us, it'll just be 5.11 forever. The branch version is a distribution-specific version, and in OmniOS, that is the release of OmniOS that you are on, that the package was built for. And then finally, the timestamp is an ISO standard timestamp format, and that's when the package was published. And the nice thing about that is that it serves the same sort of function that, like the RPM revision or the Debian package revision. It's you didn't actually change the content of the package, just maybe some things about the metadata. So you do just a timestamp bump. Okay, a package is described by its manifest, and its manifest completely defines everything that is going to everything that the system is going to see when this package is installed. So they're the typical things that you want to deliver with a package: files and directories, soft links, hard links, but also things like dependencies and other metadata that you can add to the manifest. Everything is an action followed by a list of key value attributes. And like I said, it fully describes the state of the package when it's installed, and that means that you can actually verify that an installed package is still the same as what it was when it first was installed. You can make sure that all the files are the same, that they have the same permissions on them, that they're not missing anything. And manifests can also be programmatically transformed. So when you're creating a package, you can do all kinds of nifty things that normally in other packaging systems you'd have to have some sort of install script, either a pre-install or a post-install script. Most of those things are first-class actions now, so we don't have to use any scripting. In fact, we're not allowed to use any scripting because scripting is by definition open-ended and unverifiable. So this is what a package manifest kind of looks like. This is an example of our web application package. The set action at the top is package level metadata. So there are a few things that are required, like you have to have pkg.fmri, you have to have a summary and a description and a publisher. Those things are required, but there are a few other things that are optional, and it's arbitrarily extensible. So if you can encode business-specific things in these kinds of ways. You can define what the attributes are and what their values are, and clients can look at those and be told to pay attention to those other things. One of the optional things that's provided for you is the human readable value, the pkg.human version, and that's really handy for us because, like I said, the package is always rolled off of a Git repo, and that Unix timestamp doesn't tell the user a whole lot about when that was. I'd have to turn that back into a date string and figure out what commit that was. And so what we do is we actually just use the human readable version to encode the commit hash and a human readable date string of when that commit went in. So you can do a pkg info, immediately see, okay, I have this version of the code. A directory has the typical attributes, the owner and mode and group, and a path of where it's going to land. And notice that the path is relative because you can change the root. That's a typical packaging thing. You don't always install into /, but we always do. File content is handled in an interesting way in the repository. When you publish a file to a repository, it's ingested and lives in the repository by its hash. And that's a SHA-1 hash of the uncompressed contents of the file. And that means that for multiple versions of a package that have the same files in them, you only have to store the file once. And the manifest is just a reference to a file in an object store. It's kind of the way that Git stores things, if you're familiar with the internals of Git. The file action is a little bit unusual because it has a positional parameter that's not a key value store. It's just the first thing in the line is the hash. That's a little weird, but the other attributes should mostly be clear to understand. There's the compressed version because the files are actually stored gzipped in the repository, so there's a hash for the gzipped version as well to make sure that it hasn't been corrupted. Path, the compressed size and the uncompressed size are there, so when you have a transaction, it can tell you how much data needs to be downloaded and how much is going to be actually sitting on disk when you're done. Soft links have a path and a target, and dependencies declare other packages with various types of dependencies. And that, I'm sorry. Yes. Well, I wouldn't call it an abstraction layer. We have a strategy. I'll get to that a little bit later. So yes. Dependency types. The typical ones that most packaging systems have require, obviously, this is an essential package, so if you install my package, you're going to get this other one. You can include in a version in the dependency action to say, I need at least this version of the dependent package. An optional dependency will not cause anything to be installed if it's not already, but if that package is installed and you have specified a version, then the version has to meet the same constraint. And the constraint is the same for required, just sets a minimum version. Now, the dependency type that is new in IPS and that I think is pretty cool and actually has become very central to how we deploy software is the incorporate dependency type. It's also an optional type, so it doesn't cause anything to be installed, but it sets both a ceiling and a floor. It sets a minimum and a maximum version to a given degree of precision. So you can have a range of versions that you allow, or you can have an exact version that you allow. And neither anything below that or above that will be allowed. And the way that works is, so first of all, versions and dependencies for require and optional, any version of a package, you just don't specify a version. If any version will satisfy. If you want just it's basic semantic versioning, you just get more and more specific to have the minimum be more specific. But okay, so in the incorporate, the same version specification means something slightly different. So if you say at 2 in require, that would mean just 2 or anything above 2. But in incorporate, that means 2 only. No 1.x, no 3.x, just 2.x. And then you can get more specific from there. So you can allow a range of things, or you can go exactly all the way out. And that includes the other components of the version, not just the upstream software's version, but all of the package versions can be specified there. So in practice, this is how we make our gating package. It is actually just an incorporation package. We call it Circonus incorporation. And when we're deploying the software, we install this package very early on before we install anything else. Because it's optional, that means that it's free. It's just setting some version policy in the installed system, and it doesn't actually pull in anything else. And it sets the parameters for what's going to be allowed to install. Whatever we get around to installing, it's going to match these requirements. And the handy part about that is that after the incorporation is installed, if you run an update on any of our packages, they generally will not allow you to update to anything. The exception for that is that timestamp bumps, we assume, are fine. So you can do those, but you can't do anything beyond that. So this is another example of a manifest, and this is in an incorporation. We don't actually deliver any files or directories or anything else. We just have the required stuff at the top, and then a whole long list of dependencies. This is just a little snippet of it's every package that we ship is represented in that incorporation. And note, like I said, the versions that we specify here do not include the timestamp. We assume that if it's just a timestamp change, that it's not going to be a major change. You should be able to do that at any time. So just as a little contrived example, I set up the incorporation on a system and installed some packages, and then I upgraded the incorporation so that you could see that all of this stuff happens in the same transaction. When I upgrade the incorporation, it moves everything that has a change forward to a new version as allowed by the new version of the incorporation package. Okay, so now you're all OmniOS packaging experts. Now we're going to get into how we deliver the on-premise stuff to our customers. And remember how I said that we're not just OmniOS, we're also Linux, so we have to deliver the same stuff even though we can't use the packaging system. We have to translate that somehow into something that can be done on Linux. So the way that we do that is in the build system. Its ability to produce an RPM package means that it takes the the IPS name and transforms it into an RPM acceptable form. And that means we basically just take the publisher name and we change all the slashes to dashes, and then we stick the version in there, and it's an RPM. Yes, question?
Do you read the manifest file directly to generate RPM packages, or do you have an intermediate step that follows the parsing of the manifests?
The question was, do we read the manifest to figure out what we should call the RPM? No, in fact, in the build script, the name that we put in the build.sh is the IPS form name, and we just take that and do a little transform on it, and then. No, because in fact they may not exist because they're being built in parallel. They're being built at the same time, like off of the commit job.
There's another Linux distro that takes those manifests and generates Debian packages.
Yes. Yes. Yeah. So what Dan was saying was that there's another distro that uses the IPS metadata and generates Debian packages for the operating system, and that's an interesting approach. We don't actually do that. We just built it all into the build system. We do that at a slightly higher level of the stack. No worries. So RPM doesn't really know anything about this concept of incorporations. RPM, dates back to the mid-90s. The internet was in its infancy, and people were just shipping files around. The dependencies are relatively primitive. You can do some sort of like minimum dependencies. You can do greater than or equal to a given version. I tried to use Yum version lock for a while. Version lock is a plugin for Yum that you can say, don't upgrade this package past this version. It doesn't really work the same way as in incorporations. In fact, I found that if I didn't have a package installed and then I said Yum version lock to this, I couldn't install any version of the package. So it didn't really work the way that I wanted. And it was going to be difficult to manage updating that policy for hundreds of different packages. So we just punted on this and said, we can't really keep Yum from trying to install the latest thing that it finds in the repo, so let's just not have it in the repo until it's ready to be installed. So we actually have 2 repos for Linux, and we publish packages to our staging, what we call pilot, and when we're ready, we promote things over into the public repo. And that's all a scripted procedure that when we update the incorporation, I'll get into this actually in a couple of slides, we figure out what the RPM equivalent is, and then we go look and see, is that already in the production repo? Is there maybe just a RPM rev change? To figure out the list that we need to promote and then promote it. So I wanted to get into the promotion process. So when we have a change and it's a new week and we want to promote stuff out, so we start with OmniOS and we roll that incorporation on a Friday, and come Monday we figure out, okay, what was it? If we made any changes and we rolled a new incorporation, we just make sure that we get the one that we know we want. And we run a script that looks at that git hash and figures out the version, the actual package, FMRI version, and it just publishes that from the staging to the production repo. The dependent packages on OmniOS, and this is a little bit weird, but we actually, for most of our packages, they all publish to the production repo. But users can't get them because they have incorporations installed that don't allow them to get those new versions, and all we have to do then is just publish this metadata package over to let people move forward, to show them that there's an update to the incorporation. It saves us a little bit of trouble because it's not just a single file like it is in RPM, it's a whole bunch of packages that you have to suck down and publish back up to another repo. That's kind of a slow and clunky process, so we just avoid doing that. So when it comes time to promote Linux, we actually refer to the same commit that updated the incorporation in the build repo, and then we read a JSON document that we produced at the time and figure out what all the new versions of the packages are. We translate them to their RPM equivalents. We look in the staging repo to see what the latest RPM rev, in case we built a package multiple times at the same version. We find the latest one, we get a list of RPMs, we copy them over, and we're done. So I mentioned that when we update the incorporation, we produce this JSON document, which is basically all of the same information that you would find in the manifest in a more programmatically easy to parse form. So for the web service package, this would be the snippet of the JSON file that the promote script would read. It would be able to tell exactly what the component version is and use that, plus the naming format that we translate to into an RPM file. And it would find that file in the staging repo and copy it over to production. And interestingly, the OmniOS, the package client on OmniOS, the catalog that it downloads from the repository is stored locally in a cache as a gigantic JSON document. So JSON was a nice natural choice for this, to just suck that information in and then write it back out in a slightly different form for just one per package. So as an example, let's say we're developing and we fix a little UI bug, like a CSS or a JS bug, in the public SaaS version. So the developer will test the fix and make sure that it works. They'll push to staging, they'll test it again on the staging site, and if everything's good, they'll deploy it to production. And this usually happens for all but the most complicated bugs. This usually happens all on the same day. So by the end of the day, on that day, public SaaS has the fix, and everybody that's using the public SaaS has already got the fix. So on Friday, we do that scheduled build of the web application, and when we go around to update the incorporation, it includes that package change, and then on Monday, when we move the incorporation out to the new to the production repo, everybody can now get the fix that will tell them it'll be in next week's release. And if it's not the web service package, then it would probably have been built as soon as the bug was fixed in whatever the other source code was. The package would have been created at the time that the Jenkins build fired and ran everything. So all we do at the end of the week is just say, hey, here's all the things that changed this week. Let's get ready to promote those on Monday. So everything's been promoted out to the public repo now. Now we actually have to get it onto machines at the customer premise. And the way that we ended up doing this was to kind of use Chef Solo in a way that it wasn't really intended to be used, but it kind of works well enough to get us what we need. Because we're a distributed system, we're running on multiple different machines at the customer site, and they have worked with us to figure out like which machines are going to run which roles, and they all need to be able to figure out what packages they need, what configs they need, apply any of the site local changes that they want. And those site local changes are provided as a data bag. So if you're familiar with Chef, you know that a data bag is just this thing that you can drop in that has arbitrary data in it that it makes it available to all of the cookbooks. And so we use that style to let our customers tell us what the actual machines and IP addresses and any other information that's specific to their site, like what's the domain that they're going to use, all that kind of stuff. And any tunables for the product. So if you want to have a widget special format, you can drop that in, like a yes or a no or whatever. Those tunables are all provided to us by that one file. And so what we do when Chef runs is that it looks at that site config, it figures out, like, I know, okay, I'm this node, let me find myself in this, and this tells me what roles I have, and what roles I have tells me what packages I need to install. It templates out any kind of configs, it sets up services, and after the initial install, you can continue to run this at certain intervals or whenever you want, and it will make sure that everything's kept up to date. So this is how we update the product, as well as do the first time install. And it keeps everybody in sync with the releases, the code that we have available in public SaaS. And the key thing that it does is it knows how to get services running. So it does the first time enablement of services, as well as every subsequent run, making sure that they're still running and they're still in the correct state. And that just about does it. So I've got a little bit of time. Are there any questions? Alec.
Yeah. So in terms of the
Yeah.
you allow customers to consume them in various cadences.
Yes.
Obviously makes sense because forcing them to, I know some of your customers are. It wouldn't react kindly to that.
Yeah.
What kind of support problem does that create in terms of like what your spectrum looks like in terms of how wide that is, right? If somebody's just waiting for a feature and they don't want a feature for 3 years. Like, I realize you guys are still kind of getting going, but
Yeah.
what does that look like now, and what does that look like to you down the road?
So the question was, I think, what is the support impact to having customers update at different frequencies? So we have some customers that really don't like to upgrade very often. They're happy with the stability, and so they can go months without getting any updates. But typically, people don't generally go that far. And maybe 6 months on the outside is, it seems like a long time, but it's really not. Usually there will be some sort of trigger. There'll be a bug fix or a feature that they want that they've heard us talk about, but that they don't have yet. And if you upgrade, you'll get that feature. So it hasn't really been that much of a problem. We're always very careful to make sure that we try really hard not to introduce flag days. So you should be able to upgrade from any previous version to the latest. We don't make you kind of skip forward. We have a way so that in that chef data bag, you can specify a version of the incorporation that you want to stick to and not go above. So we do have a way for people to do their acceptance testing. They'll install it on a test setup, make sure that it does all the things that they need it to do, and then when they go to production, they'll say, "This is the version I've tested. Please get me up to that version, but not anything past that." So. Anybody else? Yes?
So, how do you deal with, or do you just completely avoid having any dependencies between your services where, fix the service A or take the service A requires, you got a set of things that you don't account for.
Mm-hmm. The question was, how do we avoid or how do we deal with dependencies between services? So a particular version of an internal API has moved forward, and all the consumers of it need to move forward so that they have access to that. That doesn't happen that often. Fortunately, most of our stuff is pretty stable, but it has come up, and we generally handle that through the packaging system. So the package that is depended upon to be at a certain version will set a minimum version of that. So we'll say, I'm trying to think of what the package was that we had this. I think it was a bunch of Java jar files that's shared between a bunch of our different Java components. We made a change there, and so all of the other things that depended on that package had a require on it at a minimum version, so that version or any future version, they need at least that one that made that change that everybody needs. So we handle that kind of in the same way that we handle normal change. We just set a minimum dependency there. Yeah. Yes?
How many of your hosted customers are running OmniOS?
The question is, how many of our hosted customers are running OmniOS? Actually, most of them are.
Really?
Yeah. I think I'm only thinking 2 of them that have Linux. To be clear, every installation of Circonus will have some OmniOS in it. The time series data store is heavily tested, and we understand its performance characteristics on ZFS. In an OmniOS, we really want the features of ZFS there. So, we've been doing this for a few years. It's only been recently that ZFS on Linux has gotten to the point where people might consider running it in production, but we're nowhere close to being there. We've just found that people are okay with running OmniOS.
Based on other things that are similar that I store, I would guess that you're getting really good compression ratios to these that you would want.
Yes. The question was that, do we get good compression ratios? Yes, we absolutely do. Yeah, we use LZ4, and I think on our numeric data, we usually see 4 to 5x compression. So it's really, really good. Yeah. Anybody else? Yes?
So you talked about your developers being able to push code through staging and staging onto production.
Mm-hmm.
So what are the things you have in place to basically enable that? How does the developer know that this
Yes.
There's no way, that really, that brought your system down, we need to get back anything, or?
Yeah, so the question was about how does a developer know that, how are they enabled to push changes out to production, and how do they know that the changes are good? Well, we follow what DevOps people would talk about as small, self-contained changes. So we try to stay away from the sprawling, like humongous updates that touch all the different parts of the system. For one thing, it's a distributed system, and so the changes are usually isolated to certain components, and they don't, because they're not tightly coupled, they can be updated at different times and different cadences. The vast majority, I think, of the changes that we would see on a given day are to the web application, the front end. And the way that they know that is that each developer has their own development zone, an OmniOS zone, in our Office environment. And they can commit their code there and test it and make sure that it all works. There's the entire, all of the components are in our dev environment. So they test it in their dev environment, and then we also have a staging environment in production that's a staging front end that looks at the production data. So it points at the production database. So they can see that, they can make sure that it actually does work against the real site before actually promoting it out to production. We use a tool called Dreadnought to do the one-button deploys, and it's nice because it shows you like the commit diff between what was there before and what's just been promoted, and it's got hooks into everything. So in our Slack channel, we see that somebody deployed, and we can all keep an eye on the cadence of that. Mm-hmm. Yeah. Typically, like for, let's say, like a JS bug, they'll pull up the developer console in Chrome or Firefox or whatever and verify that they no longer get whatever the error was that they were getting, or that the elements on the page look correct. Yeah. Yeah. So it's a big web application, and it's complicated. There are unit tests, and there's also, we have developers working on a sort of meta framework of testing to ensure that like the API is all wired up correctly, and that the front end things work the way they're supposed to. So yeah, it's an ongoing battle to make sure that we have coverage. Yeah. Another question?
So you said with your chef runs, you're ensuring that the services would run in that order, right?
Mm-hmm.
Is that actually a problem you run into, and isn't that sort of redundant with SMF?
The question was, in our chef runs, the service management part of it, isn't it redundant to fix services that aren't in their normal state? It doesn't happen as often with SMF, that's for sure, because the systems can recover. Usually, if something crashes, it can be restarted. It's only if it's a persistent problem. But generally, what Chef will do is it will initially try to pull something out of maintenance. So if in SMF, if the service has gone into maintenance and requires outside intervention, then the first thing we'll try to do is just clear it, because maybe the component that it caused it to go down is now there and things are fine. So we try to converge. But we also have some checks in there that if I know that I need to talk to the database in order to start this service, I'll do a quick check just to make sure the database is up. Like, can I connect to the TCP port? And if I can, then I'm going to assume that it's probably okay, and I can go ahead and start the service. And if it's not, I just won't do that. I won't try to turn that service on, and I'll let the user know at the end of the run, hey, I didn't enable this service because it depends on the database, so make sure that that's fixed, and then run me again. Does that answer your question?
Yeah.
You seem skeptical.
No. I guess it's one of those constant problems, like, this thing broke.
Yes.
Chef will fix it for me. No, motherfucker. Your stuff's broken.
Yeah, there.
Management software is not going to fix it for you.
Yeah, that's true. We tried to avoid having that problem in the first place.
So like with, especially service dependencies, you can do these little checks like, is my port up? dependency management across services.
Yeah.
I don't know if you guys haven't done anything.
So the follow-up question was about dependencies between services. How do we orchestrate that? Right now, we have to assume that because the nodes can run independently of each other, that they just need to be as resilient as possible. So they need to check for the things they know they need, and they need to have a best effort to get as many things up as possible. We're looking at alternatives that might work better, but at the moment we've got just a defined order of the different roles. So there are some roles that are more central than others. There's a database role that's pretty much central to everything that we do, and so that gets run first. So we say whatever node that the Postgres database is on, start that one first. Run things serially in that order, and that will guarantee you the best chance of getting everything up on the first run. But we can always just run it again, and just run it again and run it again. Yeah. All right. Any other questions? I'll be around. I'll be out at the Circonus booth, or just grab me in the hall and chat me up if you want to talk about a little bit more about this stuff. Thank you.